Hello, geometry students. Today during class, we were looking at a right triangle and analyzing the altitude and the leg. We'd been talking about geometric mean and similar triangles, and we came up with the altitude geometric mean relationship, which I have on the video at this point. Remember, geometric mean has two dimensions across from each other. And with the altitude geometric mean, you take the hypotenuse as part A and part B. In the leg geometric mean, the legs are across from each other, and these are the same legs. And then you're going to take the total hypotenuse of that right triangle, of the original right triangle, the large right triangle, and the closest piece of the hypotenuse. During this video, I'm going to go through a couple of examples to show you how to use these relationships to solve problems. Let's take a look at our example number 1. I see that I have a right triangle, and I also have an altitude within that right triangle. There's my altitude. So I'm looking at that and I'm thinking I'm going to be able to use my altitude geometric mean. Z is actually my altitude. So I guess I'm going to find Z first. And I'm going to use my altitude geometric mean. So my altitudes have to be across from each other. Those are going to be the same number. And then remember, it's part A, which is 1, and part B, which is 8. So this is the A and the B. So let's now substitute our numbers into our equation. My altitude is Z. My part A is 1, and my part B is 8. Okay, at this point I'm going to go ahead and cross multiply. Z times Z is Z squared. 8 times 1 is 8. We had studied simplifying radicals before we started this chapter. So now at this point, I'm going to take the square root. Z equals the square root of 8, and I have to simplify that radical now. Z equals square root of 4 times 2. Square root of 4 is 2 root 2. Let's take a look at that picture. I now need to find either x or y. X is a leg, so I'm going to use the leg geometric mean. So you're going to take the leg, and they're going to go across from each other, and that's the same leg. And then remember, it's hypotenuse, total hypotenuse, and the closest piece. So I'm looking for x. X is my leg, so I'm going to plug it into my formula now. My leg is x, and x is the same leg, so I put them across from each other. My total hypotenuse, that's the total hypotenuse of the large right triangle. So that's 9. The closest piece is the part of that hypotenuse, which is 1. Again, you're going to cross multiply, so you're going to get x times x, x squared. 9 times 1 is 9. Square root. X is 3. So this time you didn't have to simplify that radical. All right, we're looking for y now. Y is also a leg. I'm not going to rewrite the formula. I'm going to use my leg geometric mean relationship. So my leg is y, so I'm going to write y across from each other. Now, what's the hypotenuse is 9. And then the closest piece of that hypotenuse would be 8. Again, you're going to cross multiply. Y squared. Now, I know you guys are multiplying and maybe writing 72 down. I'm going to show you something here. I'm not actually going to multiply them. I'm going to write 9 times 8 down. I'm going to take the square root. That's y. Square root of 9. I'm looking for a perfect square, so I think of 8, I write 4. times 2. This is just another way to do it. If you guys did 72, that'll work. I like to do it this way. Don't have to use my calculator. Square root of 9 is 3. Square root of 4 is 2. Can't do anything with root 2. Okay, multiply those together then. Y equals 6 root 2. So we found all of our pieces, x, y, and z. Let's take a look at our next example. We've got to find z and x and y. All right, so I don't know, I have z first here, so I'm looking at z. And that's a leg. So I would need my leg and my leg. And I need my total hypotenuse. And I need my closest piece. Now as I'm looking at this, I'm going up total hypotenuse. Z and Z are my legs. I look at my hypotenuse and I'm going, okay, I got another variable there. That means that I probably need to find a different one first. So I'm not going to find Z. I'm going to move on to X. X is part of the hypotenuse. Well, it didn't work to find Z. I have the altitude here. So I'm going to use my altitude geometric mean. So I need altitudes across from each other. Those are going to be the same number. And then I need piece A and piece B. So my altitude is 5. I'm going to write 5 and 5 for my altitude, and they go across from each other. And then I need my part A, which is x, and my part B, which is 2. I'm going to cross multiply. 2x, 25, divide by 2. X is 12.5. And in this time I didn't have to simplify a radical, and you're just dividing by 2. There's no radical there. Okay, now that I have x, I actually can come back here now and I can find my z. So sometimes you might look at something and you might think about finding that variable. You're not going to be able to until later. So I'm coming back here now, my total hypotenuse, because I need my total hypotenuse underneath that leg. It's going to be 14.5. And then I need my closest piece to z, which is not x anymore. I found that to be 12.5, 12.5. Okay, I'm cross multiplying. Z squared, 14.5 times 12.5. I'll multiply 14.5 by 12.5. Because of the decimal, I'm not going to be able to simplify the radical. I'm going to have to punch that in my calculator. I'm going to hit the square root here. And z equals, I'm going to have to round to 13.5. The last thing I need to find now is y. And you could do your leg geometric mean if you guys are thinking about that, because y is a leg. You could use your leg geometric mean, where you do the leg across from each other with the total hypotenuse and the closest piece of that hypotenuse. But I'm sure some of you are looking and you're saying, hey, Pythagorean theorem. That's what I'm seeing too. This is 5, this is 2, this is y. I'm thinking Pythagorean theorem is going to be faster, so I'm going to do that. I'm taking 5 squared, 2 squared is y squared. I got 25 plus 4 is y squared. I got 29 is y squared. Y is root 29, and I'm leaving that as a radical, guys. All right. Well, good job tonight, and I'll see you in class tomorrow.